Um, Hi, I'm Ivan Suarez Martinez, and I'm going to present my first activity of microcontrollers module of the class. First of all, I want to show the programming control. In this case, it's the MPLAB IDE. Um, Using the PIC 16F877A configuration. These are the configuration uh, bits. In this case, the most relevant configuration is the HS for the frequency used in this activity. It's 20 megahertz. These are some variables and constants used in the LCD display. Then the definition of the pins, the switches for module the control, the mode of the system in manual and automatic. Another definition of the LED, the LED A, it's in the second pin of the C block of it corresponds to the automatic LED, and the third pin of the PIC also in the C block corresponds to the manual mode. Then we need to initiate the ports of the microcontroller. Um, these are just the definition of what type of pin it's going to be in the program. Then the configuration of the ADC function. Something important I want to add in this part is that I don't declare the channel of the analog signal because we need two analog channels. Um, um, I will show you what how I solve this problem. Then the function of the mode I called loose modos to interpret the user configuration of the system. Um, this explanation is in the report, in the written report. Then the loose models, the light models, the light modes in the program. It's called loose models man for the manual mode. In this case, also is a logical loop where the system analyzes the entrance in the digital pins of the PIC, and it will work based on these users configurations of the user settings. In this is the part where I solve the problem of the analog channels. I made in two independent functions, which are called layer temp, that declares the pin of the microcontroller that will read the analog signal of the temperature, and layer loose, that declare the pin that the microcontroller will use to read the analog signal of the light or of the solar panel. These are just some configurations for the LCD display, and for the data on it, and the text also on it. These are just the LCD functions, and these are not. This is another section that I would like to explain a little bit. It's the temperature function and the light function. In this case, I use this syntax of code to to save memory of the PIC. As it shows the IDE, I only use 46% of the PIC memory, and it's a good fact, because I use entire data instead of float data. Well, this is just the work that the PIC will do, and then the LCD display will interpret to work. And also I declare these functions to just call it in the general loop, the main loop that it's in here, to save also the memory of the PIC. In this case, as I mentioned in the grading report, I try to do a loop for the manual to the of the automatic mode, because of the nature of the logic of the analog signals, that it needs to I realize that the PIC needs another lecture to show the correct value of the signal. So I call the function of the light pin to the automatic mode a lot of times to have a correct value 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 display. Also, it's the same syntax for the temperature mode. In the case of the manual mode, it's quite easier, as because it's a loop. So I don't care if I just call one time the function; it will repeat and repeat and repeat the same process until I change the sensor pin of the digital control system. And this is the end of the code. Then I would like to pass to the simulation. As I mentioned, I use the Simul IDE for simulate my system. I don't have Proteus because I use Mac operation system. So here is the simulation that I could make. Here is the introduction messages, and it's the simulation. It's in the automatic mode, and here's the program working. Temperature, I will change here. Like as I mentioned, I use entire values, so I don't have decimals in the LCD display. Look, here's the change in the light, and it works in the automatic mode. This is what happens when a contradiction happens. Let the system select a valid option. When a logical contradiction occurs in the system, the LCD display will show an error message. And the manual mode also, it's a logical contradiction. Then I will use I will select just the light pin. Then I disconnect it and activate the temperature pin. Yeah, this is how it works. I will pause it. Let's pass to the implementation, the physical implementation part. Here's my video that of my final circuit, and this it doesn't appear in the screen, but the solar panel is connected right here to in the first the first pin of the C block of the PIC. And here's the configuration. I use a pot of 5K of ohms of resistance, and here is show how I change the mode. And here are my two LED control signal. Yep, this is how it works. And in this case, here's the op-amp working. The LM35 sensor just generates analog signal from 0 to 1 volt. So I need an op-amp to first to follow the signal, and another op-amp to increase the same signal to 5 volt to to a reference voltage of 5 volts. So the peak will analyze in the best way the the temperature signal. This is all of my work. Thank you.